How's it going? So in this video, I'm going to demonstrate how to use a couple different types of automotive shop lifts. So the first lift that we're going to look at is going to be our asymmetrical 2-post above ground lift, and then we will look at our symmetrical in-ground lift here in a little bit. So the first thing that we need to determine is we need to look at the vehicle that we're going to be lifting. So I'm going to be lifting this 2023 Toyota Corolla Hybrid. We're going to want to make sure we have an understanding of the construction that the vehicle is made under, either if it is a unibody or if it is a body on frame, and then what the vehicle's weight is. How we can determine what the vehicle's weight is if we open the door, we can go to the VIN tag and we can look for not only when the build date is, but also what the vehicle's weight is. So the GVRW is listed as 4,065 pounds for this vehicle. So what that's determining is this vehicle with occupants and with cargo can weigh up to 4,000 pounds. We then are going to need to determine what our lift capacity is going to be. Now in this case, our 2-post asymmetrical lift has a 10,000 pound lift capacity. So our little Corolla over there is very much under what the maximum capacity is for the lift. So we know that the vehicle is safe to lift on a weight perspective. The other thing that we need to determine is whether or not our lift or our rack arms can get under and lift the vehicle. Now every vehicle is going to have specific lift points from the manufacturer. Now the way that we can find these is by gaining access to one of these. This is an ALI lifting guidebook. These are oftentimes found with the shop lifts, and these will be a good tool that you can use for determining the lift points of the vehicle. So in this case, I will have looked up the year range for the Toyota Corolla I have, and I am going to be using the T07 diagram because it does come up here on Toyota, and I can see these dark patches or squares on the unibody construction right there are where the vehicle wants to lift. But again, we want to make sure that we're determining that this lift can actually reach these points. Because if I go to this Toyota Sequoia diagram right next to it, I can see I have 2 lift points right there, but my other 2 lift points are here on the axle assembly. This asymmetrical 2-post lift would not be able to reach the axle assembly with how far those arms can reach. So this would not be an adequate lift to lift a Toyota Sequoia of that year range. When we're looking at determining how we can lift a vehicle, we do need to understand how the vehicle is constructed. We can have 2 types of vehicle construction. We can have a unibody construction, like what I have here on this Toyota Corolla, where I have a pinch weld that goes along the length of the vehicle. Now the way that these are constructed is this is folded over and spot welded together pieces of sheet metal, and typically our rack points or our lift points are going to be where these pieces of sheet metal unite and combine. The other type of construction that a vehicle can be made of, like what I have here on this Suzuki Grand Vitara, is a body on frame. So this vehicle has a ladder frame construction where we have a set of frame rails that are parallel and going the length of the vehicle and kind of act as the vehicle's spine. The body itself is going to be mounted to that, and our lift points are going to be along this thick steel girder. Now we wouldn't want to lift on any pinch weld because those would be too weak. As you can see on this vehicle, there isn't one. Now our ALI lift guide will point these out and give any notes if there's anything in particular that we need to watch out for when lifting these vehicles. In preparing the lift for bringing the vehicle in, one of the things we want to make sure is we want to make sure that the arms are fully in and away from being able to pull the car in. We're going to want to pull the car in as straight as possible, trying to make sure that we get it not only left to right straight, but also forward to back. The way that we're going to be able to get the vehicle lift centered is off of this pad right here. Now, not all shop lifts will have one of these pads, but typically a standard wheelbase car, which our Toyota Corolla there is, the tire is going to land right in the middle of this little square. Now what I like to do to make sure that I'm on the right side, left or right, is I like to have just about an inch or have the tire just on the edge of this yellow pad. Now if the vehicle is a smaller wheelbase vehicle, kind of similar to this Suzuki that I have in the air, we're going to want to have the tire just forward of this yellow pad. If it is a longer wheelbase vehicle, kind of similar to the old pickup truck over there, then we're going to want to have this forward or have the yellow pad behind the front tire. And again, that's going to be based off of the wheelbase of the vehicle and what type of lift that you're using. The other thing that we want to make sure we have an understanding is what kind of adapter we're going to be using. There's a variety of different lift adapters that you can have. You can use a spin puck adapter like this, a rectangle spin adapter, or you can have a flat pad that can go either lay flat, lift one arm up, or the other arm the other direction. These are kind of the standard of what most lifts are going to have, and you're going to have to modify it to these. One of the things to note with these type of pads is they do thread out. You want to make sure that the rubber is not damaged. We don't want any damage to any of the rubber pads, that it's not cracked or missing. And then also too, that we're not overextending the threads on these adapters. Now this adapter does have a stop so that you can't overextend this and have it be a little bit too weak. We can also have height adjusting adapters or stackable adapters for these lift pads. What we can't have is we can't double stack these. So you can use these in a single orientation, but what we can't do is we can't stack multiples of these. That typically is not allowed for the rack to function. So instead of stacking two, you can see we have longer ones just like this. And you're gonna need to kind of mix and match these based off of what the vehicle's side steps are, the exhaust restraints, and or the wheel sills as well. While we're on the topic of these style lift pads, one of the things that I do want to bring up is if we are using these large rectangular style ones and we're lifting up the extension pad, we can't have them going the same direction. So if I'm lifting up the 6-inch extension, these need to be rotated opposite of themselves. They can't be in the same direction. The reason why we can't have them in the same direction is what can happen is the car can then fall off because both of these can tip over at the same time. So you're always going to have these opposite of themselves, either facing in towards each other or rotated away from each other. Either way, that's fine. The other thing that you can do is in some situations on the back, especially on trucks, you might need the 6-inch extension, or you might have a little bit of a lower extension on the back of the lift. Either way, they need to be facing opposite themselves, and you want to make sure that the vehicle is sitting level. What I mean by level is how the Suzuki is sitting. So this is a front engine rear wheel drive vehicle, so our center of gravity is right about the center of the driver's seat, and the vehicle is sitting level on the lift so that if we remove any weight, it's not going to be countering one way or the other. If we are going to be removing like a heavy component in the engine, then we do want to make sure that we're running a pull jack on the back so that the vehicle does not fall over the other direction. I've got the vehicle pulled in level, left to right, and I have the pad centered on my driver's side front tire with just a little bit of the yellow pad exposed. From here now what I can do is I can set the lift points with the rack arms. Now the adapters that I'm going to be using are going to be these threaded puck adapters that can slide in and out. So the asymmetrical lifts are going to have shallower or shorter arms on the front and a lot longer arms on the rear. So what we're typically going to do is we're going to set the front rack position first, and then we'll set the rear. Our lifting point on this particular car is this reinforced section of the pinch weld. So what we're aiming for is we're aiming to try to get the center of this lift pad to be right on the center of this pinch weld. And we're going to do the same thing for all three corners, and we're going to verify that. We want to make sure that these threaded adapters are the same height and we're not overextending them. In the case of this car, we do want to make sure that we're not getting into wrecking the sill, which we should be high enough here. We do want to make sure we're being cognizant of all the different plastic undercladding or any brake lines or electrical lines that might be in the way. It's a little harder to see on the rear of this vehicle, but we do have a extended notch. That is going to be our lift point on the rear. So we're going to set our pad, again, similar height to which we have on the front. We're going to try to center it on the middle of this rubber pad, and we'll do the same thing on the passenger side. I've gone through and set the passenger side of the vehicle to the same lift points as I did the driver's side of the vehicle. Now at this point, I can do my initial lift of the vehicle. Most racks are going to have the controls for the lift on the passenger side of the vehicle for North American lifts. We have a couple different control areas here. The green button, this is going to be my motor up button. If you hear it, you can hear the motor come up. This little lever is a hydraulic release. Push it down towards the reservoir being this, and it will release hydraulic pressure. And then my lock release is this guy, and we're using the lock release and we're lowering the vehicle. We're lowering it all the way straight down. So to initially get my contact correct on the lift, I'm going to hit the green button until I start to see the vehicle come up. While I'm doing this, I'm also listening for any crunches or cracks. Now the vehicle's just starting to lift up. Once I hit the button again, you'll see it come up a little bit. That noise you just heard is normal, that's the tires. I'm gonna go around to each rack point and I'm going to double check that the rack point is in the center of the pad and I'm contacting on the lift point so that I'm not gonna have the vehicle fall. So I'll check the front one. And the rear one on the passenger side, and then do the same thing on the driver's side. Once I have verified that the rack points are okay, I'm not contacting anything from the body, I can continue to lift. I'm gonna hit the button up until the tire comes about 6 inches off the ground. At this point, what I can do is I'm gonna go through and I'm going to shake test the vehicle. That involves going to the rearmost part of the bumper. And I'm just going to press down on the bumper, and what I'm looking for is I'm giving it a light shake to verify that it's not going to shift or fall off the rack. So with a little shake like this, I don't hear any banging or clunks, so I can continue to go up to the safe work height that I'm going to work at. So to do that, I'm just going to hit this green button. While this is going up, I'm listening for a click. So you'll hear it in just a second, right there, right there. Those are the safety locks. We want to make sure we hear 2 clicks every time the vehicle goes up in the air and until we get to the safe working height. So this is the height that I want the vehicle at. I lift it past the safety locks and I'm going to use a hydraulic release to release hydraulic pressure and lower the vehicle down onto the safety locks. At this point now, I don't run the risk of the hydraulics leaking down and the vehicle collapsing down on top of me, and the vehicle is now safe to go under and work. Now that I'm done working on the vehicle at this height and I'm ready to lower it down, there's a little bit of a sequence I need to do to get it down. So I remember I'm on the locks, so I cannot release it hydraulically, nor will my lever allow me to come down. So what I first need to do is I need to hit this green button for 2 seconds. That will lift the hydraulic ram up off of the locks. With my left hand, I'm going to pull all the way down on the safety locks, and with my right hand, I'm going to push the hydraulic down, and that will lower the vehicle. Before I do this though, however, I want to make sure that the rack is clear, there's no tools, there's no equipment, and especially there's no people. So anytime we're lowering a vehicle down, you want to call out, vehicle coming down, rack 2. Again, lower the lock, lower the hydraulics, and then go down. You're gonna hold both levers until the rack arms completely go down and the vehicle is safely on the ground. You'll be able to tell that the rack arms are completely down because the rack arms will be able to pivot. Right now they're not all the way down, so I can't pivot. I also have where this pin is lowered down. As I lower this completely, you'll see the pin raise up. Now that the pin's raised up, I have the ability to push the rack arms out. It's really important before you back the vehicle out that you push these rack arms all the way clear from the vehicle. And then we push in all the lower arms. This way when we back the vehicle out, we're not running the risk of hitting the tire on this rack arm. Now I have this Suzuki set up on a symmetrical, meaning it's down the middle of the vehicle, 2-post in-ground lift. There's a couple things that are a little bit different with this lift versus the 2-post above ground. Because it's symmetrical, we're wanting to have the center of gravity of the vehicle dead center over the middle. We're going to use the same theory with checking the weight of the vehicle versus checking the weight of the lift. The vehicle is roughly 3,800 pounds and the lift is around 10,000 pounds. I believe this is actually a 12,000 pound lift, excuse me. In this case, the vehicle is a little bit lower trek width, so it means it's a little bit narrower. As you can see, I've parked the vehicle just before the yellow pad. Now my controls for this style lift are going to be remote, so they're going to be against the wall right here. Our locking mechanism is going to be pneumatic instead of a cable, and we're going to have these up and down buttons. Now to lift the vehicle up, We're gonna hit the hydraulic button up. That will allow the vehicle to come up. As long as we haven't heard any clunks or clanks, we're gonna go through, double check the racking points, and then do a shake test, just like we did on the 2-post. And then we'll be able to get it to the desired work height. If this is the desired work height that I want to have it work at, I need to lower the vehicle down onto the locks. Now, because these are pneumatic controlled locks, it operates a little bit differently. So instead of having a hydraulic release lever, I have these up and down switches, and then I have this button that goes lower to lock. So as I press this, the vehicle now is stable and on the locks. To release the vehicle off the locks, I'm going to hit the button up for 2 seconds. And instead of hitting anything else, the only thing I need to hit is the down button. So I'll call vehicle coming down on rack 3. I'll hit this down button. It will blink, showing that the vehicle is coming down. And then once my rack arms are completely down on the ground and the weight of the vehicle is supported by the ground, I can kick the rack arms out and drive the vehicle out. So right there, I would have the rack ready and complete. So this is showing you the operation of 2 different styles of lifts. Now, it's really important to always refer to the lift manual anytime you're using a lift that you're not familiar with. Both of these lifts happen to be rotary, but if you're using a different manufacturer like a bend pack or a chase lift, you definitely want to make sure that you're totally in understanding of how they operate and how they function. It's also important to understand and get the racks maintained on a regular basis. But thank you for sticking around to the end of the video. I'll see you in the next one.